Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 4th. Looking at significant wave heights for the North Pacific Ocean, we see a broad area of seas, not particularly large, but pushing into the Hawaiian Islands and also pushing towards California. This the result of a gale previously on the dateline that was targeting the Hawaiian Islands well. In fact, we can do a quick recap here. This is back Wednesday, last week. You see seas partially obscured by the controls here, but 22-foot seas north of Hawaii. That was sort of the primer start of the system. The main gale started developing Wednesday night, 30-foot seas on the dateline, building to about 33, 34 feet, pushing directly at the Hawaiian Islands from a very west angle. That swell has already hit there. It peaked on Saturday, fading on Sunday. Still a good solid surf hitting there, and swell is radiating now towards the California coast. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet, falling to the south, like right there. So that would help support a counterclockwise flow aloft and also down at the surface. And of course, that's the hallmark of low pressure. Low pressure, of course, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, produces swell. And when that swell impacts your beach, that produces surf. So this has been the pattern all winter. Pretty healthy flow, pushing off Japan. When the active phase of the MJO is controlled, it pushes it to about 155 west, and then the jet splits, just like it's doing right here. You see the northern branch pushing up into British Columbia, the southern branch splitting again, part of it going into Mexico, the other part down at the equator. Between this split jet flow, you have high pressure, and of course high pressure for the most part produces clear blue skies, no precipitation, no weather, and it also directs the storm track north of it. So the main focus of all our swell activity this year has been out in this region, and the pattern continues with the active phase of the MJO in control right now. Rolling this out, you see, trough continues, kind of a pinch trough, not broad, not really open. As we get into Monday, wind energy, though, starts building off Japan to, what is that, about 210 knots. There we go, 220 knot winds. That's a very strong jet stream flow ridging, then falling into this, again, pinch trough here, not super supportive of gale development. You need a broader trough, and then the split continues east of there. Anyway, we'll roll this out into Wednesday. The pinch trough really pinches off solid by then. Support for gale development will probably drop off at that point in time. And then we get into Saturday. We're almost a week out now. The jet stream backs off energy and only 140 knot winds. Not bad. Trough developing here on the dateline while more wind energy builds over Japan. Roll this out. See, pretty decent, well-formed trough. Wish it had more wind energy building into it. Of course, the split pattern, the ridiculously resilient ridge, as I call it, because the jet stream ridges to the north, again, supporting high pressure, starts building pretty solid on Sunday, a week out. And then wind energy, again, to 190 knots, pushing off Japan on Sunday, and looking like to set up more of the same pattern, which is not a bad pattern. Pretty good for storm development on the dateline, but nothing good for California to come from it. Next up, let's take a look down at the surface. And as you can see right now, generic low pressure, 984 millibars, generating a flow of 20 or 25 knot northwest winds. That's not enough to produce any meaningful swell. And as expected, there's our high pressure, 1028 millibar high, sitting right off the California coast. The jet stream, remember, part of it's going up here, part of it's going down here. The high sits right in between the split flow. Anyway, looks like low pressure trying to organize off California on Sunday morning. And as we roll out, we see, sure enough, we get into Monday, a little bit of a low, 40 knot winds, continuing to the dateline into Tuesday, and then fading Tuesday night. That might be good for some swell production, but then it doesn't make it any further than just barely over the dateline. Then another series of small bits of energy, nothing really organized though. High pressure holding strong off of California. So we get into Thursday, Friday, and then Friday another system develops. Remember, the jet stream's a little bit better organized then. 40 knot winds forecast. building to 50, almost 55 knots. That would qualify as a storm. And that aimed a bit at Hawaii, also at the U.S. West Coast. Almost looks like the high is trying to break down a little bit, but you can see we know the jet stream's ridging to the north. That pushes the storm off to the north. The jet stream is what drives the storms down or gales down at the ocean surface, helps direct their track, and that's exactly what's going on here. And as we get into Sunday, that system lifts off to the north. Looks like another system trying to develop off of Japan. Hard to believe any model that far into the future. High pressure in the meantime, generating, looks like north winds, but not getting to Hawaii, so just sort of an open ocean wind swell, if nothing else. Let's take a look at the effect of these winds on the ocean surface. And here we are, significant wave heights for the North Pacific Ocean. This is the highest 1/3 of waves generated. You don't care so much about the bottom 2/3. It's the highest 1/3 of waves that produce. Well, that's actually, gives you a good sense of what's going on in the ocean from a significant standpoint, not from a noise standpoint. Anyway, looking at the models, not a whole lot going on until Monday night. Small gale, as we saw, expected, builds off Japan, 28-foot seas, and never really exceeds that, making it to the date line, falling apart. Certainly swell will be generated from that. 28 foot, probably about a 15, maybe 16 second period swell. Targeting Hawaii because Hawaii is closest. Sure, energy will reach California, but it'll be very inconsistent and pretty well decayed by the time it gets there. Then we have, again, spurious little pockets of 23-foot seas. Nothing too much until we get into Saturday, and then we get our storm developing on the date line. Small storm, 30-foot seas, and building, but notice most of the energy pushing northeast, probably focusing more on central California northward, not some sideband energy for Hawaii just because they're close, but most of the energy pushing up probably into Canada. And then where we're at, there we are, 180 hours out. So the pattern, at least from a storm production perspective, not super consistent, not super large storms, most of them short duration with a small fetch area. This is pretty much the hallmark of La Nina. During El Nino years, you get the opposite. You get more storms. They're broader in coverage. They last longer. They push further across the Pacific, and the impact or the swell resulting from them is much stronger, much more widely felt. And just for laughs, we're looking down south, and because on Wednesday of last week, a small gale developed in the southeast Pacific, 28 to 30-foot seas, mainly pushing east. The point being, and then out of the California swell window, the point being a small little pulse of southerly swell is expected for Southern California about a week after this, so later this coming week. Nothing significant, but considering the relative lack of surf in Southern California, this will be noticeable and it will be rideable, but nothing exceptional. Let's do a quick look, zooming in on California, Hawaii winds. High pressure, the main influencing factor, producing on Sunday a light north to northeasterly flow. South winds or southeast winds over the Hawaiian Islands. You can see almost the line here where the split sets up in the jet. Right there, about 150, 155 west. Anyway, south winds continue into Monday for the Hawaiian Islands, and but notice a high pressure building off of the California-Oregon coast, almost like a small summertime gradient developing. North winds 20 knots down to somewhere around Point Reyes or so. And that continues into early Tuesday, then starts lifting north, pulling away from the coast. Better conditions probably in the San Francisco area and central California. High pressure ridging into Oregon that's just blocking down, providing no hope for precipitation for this area. And then that continues. Notice the high pressure building, ridging into the Pacific Northwest as we get into Wednesday. Thursday, light wind pattern sets up Thursday, light offshore for California. North winds for the Hawaiian Islands at that point in time. High pressure driving that. 20-knot north winds later on Thursday for Hawaii. And then we get into the weekend. high pressure building strong over British Columbia, sets up again more of like the summertime kind of gradient thing, 25 knot north winds over Northern California, building some and then fading out on Sunday, and we get back to a light flow. Northeast winds continue for the Hawaiian Islands. And a quick look at precipitation. We were looking mainly for the U.S. West Coast here. You see high and dry. There's the high pressure. Storm track over British Columbia. We'll roll this out. Again, pretty much the dividing line this winter has been between Oregon and Washington. High pressure then really builds in another little patch of precipitation Wednesday, Thursday for British Columbia, and then fading out. High pressure takes over at that point in time. By next weekend, not even precipitation up into British Columbia until maybe late in the period, and then very minimal, if anything. So this is a typical La Nina sort of pattern. Remember, cold water is due south of California, and it's wherever the cold water is, or colder than normal water, that's where precipitation is suppressed during La Nina years, and then during El Nino years, wherever the warm water is, that's where precipitation in the jet stream is enhanced. And that sets us up to talk about the long-term outlook. What's going on with the Madden-Julian Oscillation and El Nino La Nina? As usual, we like to start looking at winds on the equator, specifically in the Kelvin wave generation area. This is the East Pacific here, and this is the equator right there. So Ecuador would be about right over there, and that is New Guinea, the Philippines off the chart here. The Kelvin wave generation area from 5 north to 5 south, from about 135 east out to about 170 west, this box right in here. These winds are from the TAO buoy array, series of buoys strung across the equator used to monitor, originally put in place to monitor El Nino, but they also are a good way for monitoring the state of the MJO. Madden-Julian Oscillation, when in the active state, tends to suppress trades in the West Pacific. That feeds energy to the jet stream, and then, of course, feeds the storm track. During the inactive phase of the MJO, it enhances trades in the Kelvin wave generation area. That means winds are harder from the east, and that causes the jet stream to split. So right now, looking at the equator, east winds, trades, normal for this time of year. At least that's the way it appears until you get right here, and the Kelvin wave generation area starts a little bit over here. But notice, one little barb, two barbs of westerly winds. So that's actual winds, anomalies, differences from normal from this time of year. And we're just looking at the wind arrows. Looks pretty normal until you get over here into the, let's say, the central Kelvin wave generation area. Westerly anomalies starting to appear. We know that to be the case. We also know that the active phase of the MJO is moving over that region. Now, this is 5-day average or mean winds, so it sort of lags behind a couple of days of what's actually going on at the surface. But it is real sensors on the ocean surface measuring wind speeds versus models versus satellite versus other stuff. So it's a very conservative but true measure of what's happening. Looking at the past 5 days, 850 millibar vector wind anomalies. So these are winds up about 4,000 feet, which are a reasonably good proxy for what's going on down at the surface. The oranges and the reds are westerly anomalies, the blues easterly anomalies. There's South America, there's the Philippines, New Guinea's right there. Kelvin wave generation area right about in this area right here. And you see sort of a mixed bag that was back on the 29th. But as you follow down through this, you see westerly anomalies building consistently towards the Kelvin wave generation area, and as of February 2nd on the date line, indicating, at least from this chart, the presence of the building active phase of the MJO. And then here's another view of the same thing, 850 millibar zonal wind anomalies. So this is only the east-west component of the wind. Blues suggest easterly anomalies, red suggests westerly anomalies. Kelvin wave generation areas in between these two tick marks right here. And you see in January, we had a lot of easterly anomalies, very strong on the date line, indicative of the inactive phase of the MJO. And yet we see westerly anomalies slowly trying to work themselves off to the east as we get later into January. And then about January 30th, it looks like the active phase of the MJO really woke up. There's 180 west, so the Kelvin wave generation area ends right about there, filling the Kelvin wave generation area for about the past 4 days or so, 5 days, and still building to the strong category by tomorrow, and then expected to hold in the Kelvin wave generation area for the next 7 days. That is a good sign. That would be conducive to feeding the jet stream, and of course then also feeding the storm track. Next, we look at outgoing long-wave radiation models. This gives us a little bit further look out, 2 weeks out, 15 days. All right, so there's Australia, there's South America. Kelvin wave generation area, you can draw a box right around in here, and you see the blue. So this is outgoing long-wave radiation. That means how much sunlight is reflecting off the ocean's surface, basically. Blues suggest negative anomalies, meaning more cloud cover, meaning low pressure, meaning the active phase of the MJO. Reds suggest a lot of sunlight reflectivity, suggesting high pressure, suggesting the inactive phase of the MJO. So, according to this, the active phase of the MJO is strongly entrenched over the West Pacific towards the dateline. The inactive phase of the MJO is locked in the Indian Ocean. This active phase, by some accounts, not all, but was one account we saw suggested it was the strongest active phase in 20 years. We find that hard to believe given the atmospheric response of what's going on right now, but a data point to consider. It's still a strong active MJO. And looking down here, the forecast per this, the statistic model suggests the active phase is to move off to the east and start pretty much moving out of the Kelvin wave generation area in 2 weeks, while the inactive phase starts filling into the West Pacific. Interestingly, the dynamic model, the GEFS model, suggests the active phase is to hold dead solid and hold its strength for the next 2 weeks, keeping the inactive phase balled up in the Indian Ocean. This is the preferred outcome, but normally what happens is some sort of a synthesis between these two models is what actually results. So the expectation is the active phase will probably ease off and weaken some over time, but not as fast as what the statistic model suggested. So next up, we look at phase diagrams, just another way to track the active phase of the MJO. Assume you're looking down on the north pole of our planet, and the active phase moves from west to east, from the Indian Ocean over the maritime continent, that's like Bali, over into the West Pacific, over the dateline, under the U.S., on the equator only on the equator, moving across the Atlantic, and then over North Africa, back to the Indian Ocean. The big dot here is where the active phase is, so in the West Pacific, and the further away from this circle, the stronger it is. And this is indeed a strong active signal per this, the ECMF model, and this model suggests basically the active phase is to hold for about another day or two, then start rapidly weakening while moving off to the east, while the GEFS model suggests the active phase, again, it was very strong also, suggests it's to hold basically where it is, just sort of meander around, weaken some for the next 2 weeks. So you see the difference in the two models. This gives you a view not only of strength, but also of positioning on our planet. And then there's the upper level model. This runs it seems about 2 weeks ahead of what actually occurs down at the surface. So the greens, there is South America, there's New Guinea, there's the Philippines, the equator running right through the middle. And the greens is areas favorable for precipitation. Think of that as the active phase of the MJO. This suggests the active phase is already moving well off and is supposed to be moving into Central America by about mid-February, while the inactive phase builds in the west and starts pushing over the Pacific as we get late into February and continues its trek into Central America through mid-March. At that time, the active phase, another new active and fairly strong active phase of the MJO, reemerges in the West Pacific, developing and tracking to the east. Our favorite model, of course, is the CFS model. This is 850 millibar zonal wind anomalies. So past performance is here. You can and the Kelvin wave generation area. There you go. So roughly from here to here and you go basically you can draw a column the whole way down this chart right there. Just looking at the Kelvin wave generation area, that's the influential area for feeding the jet stream. Right now, the yellows suggest westerly anomalies on the Kelvin wave generation area. Here is that big blue blob of easterly anomalies that happened pretty much all through January. Westerly anomalies in control. We can assume that that means the active phase of the MJO. Let's overlay the MJO. Sure enough, there you go. Active phase of the MJO, pretty strong, solid contours. On the date line, still not at its peak, another couple of days to go. That's supposed to hold through on the date line to about February 20th. So another 2 weeks or so. At the same time, the inactive phase, the dotted contours are the inactive phase, starting to build into the West Pacific. But notice the whole way through this, yellows, westerly anomalies forecast holding at least into sometime in March. That if that materializes, that would be a significant change. Inactive phase of the MJO still supporting weak west anomalies. Interesting. We'll talk about that in a second. Anyway, and then as we get into, let's say, first week in April or so, the inactive phase fades out. The active phase returns, but when you're into April or so, the active phase has less and less of an impact on the northern hemisphere storm track. You're into spring by that time. So the reality is this could be the last real active phase of the MJO for this winter, which isn't saying a whole lot because we haven't had a whole lot going on, but just something to note. All right, so then let's put the low-pass filter over here. So this is the interesting part. The dotted contour is, you can sort of think of this as El Nino, La Nina. The dotted contour is a bias towards high pressure, and you go back here into October, you see the bias towards high pressure was pretty much filling the Kelvin wave generation area, and the solid contour was all over in the Indian Ocean. And think last summer, there was a lot of solid storms in the Indian Ocean. That was all supported by this bias towards lower pressure that was focused over the Indian Ocean. Now notice, as we get into the next 2 months, the high pressure bias starts fading off to the east, right? There's the date line right there, going right up there. The the high pressure bias moves out of the Kelvin wave generation area sometime in mid-March, and the low pressure bias starts moving from the Indian Ocean more into the western Pacific as we get into April, suggesting the end of La Nina. I mean, we've got a bunch of signs of that already if you follow this broadcast weekly. You know we've been saying that La Nina is past its peak, or there's signs of it. This is yet more data suggesting that is the case. And just one quick check here on our MJO strength indicator chart, giving us some historical perspective. January 2018, here's the current building active phase. This runs a little bit behind, maybe a week behind. It doesn't show you where the active phase is. It just shows relative strength compared to previous active phases. So the big spikes here in 2015 were, of course, during our Super El Nino. Of course, that would be expected. And that even hung into January 2016. And then remember last summer, when there was literally no surf at all, there was no MJO activity. The thought is this building active phase here, hopefully it'll go a little bit higher, and hopefully it'll feed the jet stream and build some storm activity and some swell. But we'll see. You never know. All right, so let's talk about what's going on in the ocean, because the El Nino, La Nina thing and the MJO, it's an interaction of not only the atmosphere but the ocean, and the two of them work together to affect global weather patterns. Right now, we're looking at subsurface sea temperatures. East Pacific here, West Pacific here. There's absolute temperatures. These are the anchor lines off the TAO buoy array. This is on the equator. These are the series of buoys strung across the equator, and the X's are the sensors on those anchor lines. That's where the data is obtained from. The actual color scheme is it's a modeled view, okay? There's not enough data points to be able to map it all out. So again, we use a model to sort of get a sense of what the positioning of water temperatures are. You see warm water here in the West Pacific. This hard line here, this is the 26-degree isotherm. It was at about 180 west for much of the winter. It's retreated to 175 east. The thought is, remember, trades are blowing hard here, and that's causing upwelling on the ocean surface, pushing cool water this way, and it's sort of keeping warm water balled up in the West Pacific. The 24-degree isotherm here is actually, it was hanging around 130, 135 west, but this heavy line, notice it's not only to 120, but it's starting to show signs of building at the surface as well. Another hint that maybe La Nina is fading out. But notice, temperatures still, warm temperatures, very shallow in the east, much deeper in the west. Typical La Nina kind of pattern. Now here's anomalies, differences from normal for this time of year. Again, we see warm water, 2 degrees, the far West Pacific. There was actually a finger of warm water that made it all, almost out to here. Last week, the week before that, we thought it maybe was a Kelvin wave from the previous push of previous active phase of the MJO. And still, there is some warm water here, and that significantly cut into the cool pool that was here. That is the hallmark of La Nina. But now we see cool water starting to build again, 1 degree below normal at depth and at the surface. So suggesting that cool water and La Nina is not over yet. Here's another model using that same data. Now this one seems to run about 5 days to a week behind the one above us. It still shows a pretty, you can see the outline of that warm, we'll call it Kelvin wave. I don't know if it really was a Kelvin wave, but if you had been watching this chart over time, there used to be a lot of cool water filling this whole area. This little push of warm water to the east has certainly undercut the cool water, but there's still cool water the whole way out to the dateline on the surface, just not as cool as it was, not as dense as it was, suggesting definite weaknesses in La Nina. Sea level anomalies, this from the Jason-2 satellite, strip out all the waves, strip out all the tides, strip out wind swell, everything. And you're just looking at the relative height of the ocean's surface in a perfect state relative to what it was in normal times or normal for this time of year. You see, okay, so there's Australia there, New Guinea there, South America there. This is the equator. And on the equator, actually, we have this pocket here of almost normal sea surface heights, but the general trend north and south of the equator, and mainly south of the equator, is negative anomalies, minus 10, minus 15 centimeters. That means cooler water at depth. Cooler water, of course, contracts, creates that little indentation on the surface, meaning there's still cool water at depth, but not nearly as much as there was. The picture is slowly looking better, not like El Nino or anything, but just a return or trying to return to normal. Then our favorite chart, upper ocean heat anomalies, upper 300 meters of the ocean surface, West Pacific here, East Pacific here, time going down the column here. We're back last year, warm water in the West Pacific, couple little Kelvin waves, almost like a mini El Nino. That's what helped fuel all the precipitation from last year in the winter, January, February, March timeframe. It wasn't really El Nino, but it had the effect of it. And the positioning of this warm water was due south of California into the South American coast. Then, as we got into August, cool water started developing. Of course, that was from trades building over the East Pacific, the hallmark of La Nina. Here is our cool pool associated with La Nina. And then last week we talked about that finger of warm water subsurface like a Kelvin wave. Very clear on this chart here, making it to almost about 100 west. And then you also see now the reemergence of some cool water at depth. But there isn't much of cool water left in the East Pacific. So even if the trades are blowing, there's not a whole, not like some big reservoir of cool water that's going to get drawn to the surface and upwell, just normal upwelling. So this sort of hints that La Nina has certainly had a lot cut out of it. Now let's go take a look at the ocean surface. What's going on? Sea surface temperature anomalies. Well, a vastly improved pattern from weeks and months past. There's warm water building off of Chile, a little pocket of warm water off of Peru. Now, along the immediate Peruvian coast, there's still upwelling. Trades are blowing pretty good, okay? And moving, the trade, so you have high pressure here, circulating counterclockwise in the southern hemisphere, high pressure in the northern hemisphere, circulating clockwise. That creates trades blowing from the east on the equator. When the highs are stronger than normal, which they typically are during La Nina, that creates stronger than normal trades, and that creates upwelling. But notice, there is cool water here, but a vastly improved pattern, according to this, than in weeks and months past. And it looks like even in the heart of where all the cool water originates, not so, just not nearly as dire of a situation looking, suggesting that maybe La Nina is fading. The trend for the past 7 days, oranges, yellows, suggests warming. Well, the pattern was much warmer past couple of weeks. Still, there's one little patch of cooling there and there, but the general trend is warming, not quite as warm along the Peruvian coast and Chile coast either, but warming in the deep South Pacific, suggesting, the trend is slightly warmer than what it was, certainly not cooling. But then actual sea surface temperature anomalies back it out even more. You see still a broad area of cool water here. Again, trades still blowing pretty good in this area. We know there's cool water subsurface here. The trades are causing it to upwell, causing this finger. This is the hallmark of La Nina, cool water south of California, off of Peru, Ecuador. And again, now, where's the jet stream split? At 155 west, somewhere right up here. And that's so the jet comes raging off of here. It senses the cool water here. There is not a lot of evaporation in this area because temperatures are cooler than normal. The jet stream makes some roads into that unfavorable environment, and then finally it just loses energy and splits. And that is driven by this cool pool right here. When the cool pool disappears, the jet stream can make it further to the east, eventually impacting and moving further south as well, pushing into California, and that's where your precipitation comes from. But given this semi-permanent, at least for this year, cool pool, it's doubtful that the jet stream is going to make significant incursions into California this winter. So let's talk about what's going on in the atmosphere now. Specifically, we know the active phase of the MJO is in control. This is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Daily numbers here, if they're negative, suggest the active phase of the MJO. If they're positive, and you can see we have all through January, a long run of very positive numbers, and then all of a sudden, just the past 4 days or so, 5 days, the index has dropped very well negative, suggesting the building active phase of the MJO. Now, these raw numbers are pretty noisy. We can do a 30-day average on that, get a sense of what's going on. There was our active phase, negative numbers back in December, and then here was our building inactive phase of the MJO into late January. And now notice we were up at 9.23. Now the index is falling, the 30-day average, sensing these negative numbers here. And then the 90-day average, used for sort of getting a sense of El Nino, La Nina, the super long trend, holding at like 3 to 4. That's not much of a La Nina. Positive, though, not negative. Building up to 5, and now starting to sink a little bit, basically suggesting a very weak La Nina. We were thinking this was going to go up into the 12 or 15 range. Never did it this winter. And if La Nina is already fading, then this might start working its way towards zero in the next month or two. Here's the 30-day Southern Oscillation Index graphed out over time to give you a sense of what's going on. Back 2014, 15, even into 16, the effects of La Nina clearly visible. The 30-day average negative. Then we got into 2016. Index went positive a little bit, kind of hovered around neutral. Positive again, 2017 going into 2018. There's a big spike. All these downward spikes are the active phase of the MJO. upward spikes are the inactive phase of the MJO. Here we are starting to go into active phase of the MJO. We want to see it really sort of spike way down, and that would help return us perhaps to a more neutral trend. But right now, for this year, the trend is positive at about 6 or 5 or something like that. Again, indicative of not a very strong La Nina. And then the ESPI index, just like the Southern Oscillation Index, only instead of measuring differences in pressure, it's differences in precipitation. We know cool water, there's South America, is off this region here, suppressing evaporation. So that sends the index negative, minus 1.04, meaning less evaporation, less precipitation in this area. And just another way of saying, it looks like La Nina is in effect. We want to see this guy start moving towards zero. In fact, it's been hovering about 1.04 for almost a week now. We're beginning to wonder if maybe there isn't some technical issue with this data here. We'll watch it for another couple of days, and of course send off an email if we have to and say, hey, maybe your data's hung. But in the meantime, that's what it looks like. And then finally, the Pacific Decadal Oscillation. We've talked about this. This is that long-term 20, 30-year trend that sometimes sort of favors El Nino, and then it switches back and favors La Nina. So we were in a strong, I guess you'd call it a positive warm phase of the PDO back in the 80s and 90s with the Super El Nino of 98 that fully discharged all the heat. That sent us into the negative phase of the PDO. In fact, you can see it right here. Went negative, and then that sort of sent us into this long-term trend. It was a little positive there, but you can just see massive amounts of numbers up till about 2013. So this whole, 10, 15-year block is the cool phase of the PDO, we're thinking. And then you notice here for 4 years, it's all warm data, positive numbers, suggesting, hey, maybe the cool phase of the PDO is over. Hard to say. We're 4 years into this. We haven't had nary a negative reading here in this index. Suggesting, so we've been thinking that we're moving back to the warm phase of the PDO. Hard to say. We'll give it another year. Let's go look at another index too. So here's another flavor of the same index, this from NOAA. And here you go, January 2014, the index goes positive, and it has been positive for the past 4 years. Here is the cool phase of the PDO that started, we'll see how far, there you go. There's we'll even go back further. So here is the, wow, you can see this. Cool phase of the PDO in the 70s, and then we'll say somewhere around 77 or so, it starts working towards the warm phase, right? Even during the warm phase, here's a 4-year stretch of cool numbers, so it's not impossible. And then the Super El Nino was in 98, and then we went back to the cool phase, you see, right there. And then now we have this bump of warm numbers. The question is this really a turn of the PDO to the warm phase, or is it just a 4-year break? The longest we've ever seen a break, looking at the record, is 4 years. So this coming year, 2018, it will be probably a good indicator. If the PDO starts going negative and staying negative, that would be a sign that we are still in the cool phase of the PDO. But if the numbers start working their way warm again, and it looks semi-solid through 2018, then we can say, hey, maybe we are in the warm phase of the PDO. Remember, this is at a minimum, a 15-year cycle. Most of the time is 20 to 25 years or more. So you can be 4 or 5 years into the cycle before you really know that there's been a cycle change. But the thought is that perhaps the 2014 El Nino actually pushed us over the edge. And we know there's lots of latent heat energy in the oceans, and that it's not fully discharged, and that the oceans continue to get warmer. So it would not be a big surprise if we did move towards the warm phase of the PDO. Of course, that would be good for storm production in winter months, in the years ahead, and maybe be good for our rainfall situation in California as well. And then finally, the sea surface temperature forecast in the Nino 3.4 region. That's the main region for monitoring El Nino, La Nina. Unchanged from last week, basically. In February, temps are supposed to rise a little bit. I think that was all attributed to that Kelvin wave that we just saw happen. Maybe up to, what is that? 0.45 degrees below normal. And then cool water is supposed to rebuild to minus about 0.75, about as cold as this La Nina was in the spring and summer months. And then a gradual warming trend is forecast. Other models, and there's a bunch of other models, they suggest La Nina's dying, and as we get into April, May, it should be dead. So though this is NOAA's official model, this is the outlier of all the other global models, produced at various institutions across the planet. So we'll see whether this is true or whether this is, if anything, the most conservative and pessimistic view. So that's it for this week. Right now, small swell from a gale that was over the dateline is about ready to work its way into California. So there'll be some little bit of surf, but Hawaii got the balance, the lion's share of the swell. That swell is still hitting Hawaii now. California will get a good run of 4 or 5 days of, moderate surf, nothing huge, but at least it's waves. Another gale forecast west of the dateline, and then another one on the dateline behind that. So a steady run of moderate surf is the expected result. No real precipitation for California anytime in the near future. Other than that, the active phase of the MJO is building strong. At some point, we would expect the jet stream to roar, repair that split, and push into California. But we'll see how that works out. It doesn't always work the way you expect it to. And so that's it for this week. Next week, we will not be doing a forecast. We're taking a break for a week, but the week after that, we'll be back. So enjoy. Have a good one. Bye.